Alright guys, I'm going to try to break down the second problem on the back of activity, I believe 2.7, which is vector activity. And we'll start here with this one. So if you want to use the format that this worksheet uses to solve the vector problems, that might be the best way to go. If you understood the way I solved it in the videos with north, south, east, and west, you may use that as well. I'll use their format since we're looking at this sheet. This works really well for everyone. So, well, for almost everyone. So if we look A, this is vector A, and they tell us the magnitude is 6 meters. So I can label that with a 6, right? That's 6 meters. And they tell us the angle is 23 degrees south of west. So let me erase that, and I'm going to put that here. This is 6. And if we had a horizontal line, right, we can add a horizontal line here to give us directions west and east, and we see that our vector is 23 degrees south of west, right? So it's heading to the west. That's this direction is 23 degrees below that. And now what I want to do is I want to find the x and y components. So I'm going to zoom in here on our vector, and we're going to draw the x and y components. We'll do the we'll do the y in red. And I could do this two ways. I could either go down like this, right? And I draw the arrow tip in this direction because this vector is heading down in the y direction. It's heading to the left in the x direction, or to the west. So I'm going to go like that. And here we're going to have tip touching tip, tail, tip touching tail. And now we're ready to solve this problem. Let's first label some stuff in our triangle. We have the right angle is here. We know this side of the triangle is the hypotenuse, and it is 6 meters long. I also, since I know this angle is 23, this angle here will be 90 minus 23. So if we have a triangle, or we have a right angle, right, we know that this is 90 degrees. So if you look at this, right here is a right angle. So if this part of the right angle is 23, the rest of it is going to be 90 minus 23, right, which gives us an angle. So this angle here is 67 degrees. All right, now we want to find AX and AY. AX is blue, and the way I've labeled my triangle, then the blue side is opposite of the angle, right? If this is the angle here, the blue side, the AX side, is opposite that angle, so that is the opposite side. This then is the adjacent side. So I'm going to label both of those so I know what to do with them. And now I'm going to bring out so and ka, right? So and ka. So to find the opposite side, I'm going to use sine. So I'm going to take sine of 67 equals O divided by the hypotenuse. Well, the hypotenuse we know, so that's actually, I'm going to put a number in for that. That's going to be 6. So what I'm going to do now is I'm going to multiply both sides by 6. That will get rid of the 6 on this side and leave me with O, which is an unknown. On this side, the left side of the equation, I'll have 6 times the sine of 67. Okay, when I check this, or when I solve for this, I get the opposite side, or the blue side here, is 5.52 meters. So that will go here for AX. And since this is in the west direction, we're going to give it a negative sign, okay? If you're using the system I taught in the initial video with north, east, south, and west, you don't need to use negatives. If you use this AX, AY, the X and Y system like this, then you have to use negatives, right? West is negative and south is negative. So then we look here and we want to find now AY. So I'm going to use cosine to find the adjacent side. So this math I'll do up here. So this is going to be cosine of 67 equals A divided by 6. So again, we multiply both sides by 6. And what we get for A here is negative 2.3 meters. Again, negative doesn't come from the math. It comes from the fact I know that this is south, and so I have to call that a negative to set it apart because north is going to be positive. So we've got that first part done. So now, whoop, let's not do that. Okay, so now what we're going to do is we're going to move over to vector B. So vector B, again, I'm going to draw my x component here. I've got to put the tail tip on it. As it's heading that way, I'm going to put an add tip to tail, right? So we end up here with the tips touching. That's fine. Tip to tail here is good. The angle is 40 degrees. So this angle is 40 degrees. And it is, if this is east, the vector is north of east by 40 degrees. So that's where that comes from. So then we do our math again. So we do sine of 40, right? Sine is going to give us opposite. So that's going to give us the blue side. So sine of 40 equals, oh, I forgot to label that. That's 18 meters. So our hypotenuse is 18 meters. And the sine of 40 equals O over 18. So I multiply both sides by 18. Boom, boom. That there, 18 disappears. And now we do 18 times the sine of 40. And we get for BX 11.5 meters. Should this be a positive or negative number? Since it's heading east, that's going to be a positive number. Sorry, I erased, I need to get rid of this. This obviously is the y direction, and it's in the north direction, so this is a positive 11.5 meters. And then, of course, we want to find BX. We want to find this side, so that's the adjacent side, so we'll use cosine of 40 equals adjacent over 18. And when we solve that for the adjacent side, which is this side of the triangle, we get 13.8 meters. Okay, so now I've got my two x components for my two triangles, right? So what I'm going to do now is I'm just going to add these x components together. In other words, this blue plus this red give me what? Well, they're going opposite directions. So are they going to add together or subtract? Well, they're going to subtract from each other. So I can see here that I've already got the negative sign in. So mathematically, I can just do 13.8 plus this negative 5.52. And when I do that, that gives me a CX of 8.3 meters. And then when I do the same thing for CY, or for the Y components, right? I do negative 2.3 plus 11.5. Together, those end up giving me a y component of 9.3 meters. So now I've got my two sides of my final triangle. Remember, what we're really trying to find is what happens if I take this vector, right, which looks like this, and I add it to this vector, which looks something like this. What's the end result? What's this red vector? Where am I going to end up going? That's what I'm trying to find. So keep that in mind. So then, if we go back over here, I draw a vector in the x direction of 8.3, positive x direction, which is this direction, so that's 8.3 meters. I draw a vector in the y direction of 9.3. And now I want to find, now I know that I'm walking in this general direction. So whenever I draw my resultant, right, I've got my final two components, and I'm going to find the resultant of adding B to A. That's what this is. It's got to be in the correct direction. And since I'm going east and then north, I'm going northeast. My arrowhead needs to be pointing northeast. So that's how I knew to put it there. The angle I'm finding is right here. And to solve this, I've got a right triangle. Right, here's the right angle between these two, the red and the blue, the x and the y. What I want to do now is I want to do Pythagorean theorem. So the way that's going to look is I'm going to take both sides. That's a squared. Sorry, this is a squared. This is b squared. Doesn't really matter, but you can choose either side to be A and either side to be B. But 8.3 squared plus 9.3 squared. And then that equals C squared. So when I solve this, I'm going to do 8.3 squared plus 9.3 squared. And I get C squared equals 155.4. And I take the square root of both sides. So then C ends up equaling 12.46 meters. Okay, so then so I come down here, I put my magnitude as 12.46 meters, and the answer sheet, they round this up to 13 meters. Okay, so don't worry if you got 12.46, you got it right. That's even a more accurate, precise answer. So then we want to find a direction. So to find the direction here, if I look at this triangle, if this is the angle I want, and you always want to find the angle where the two tails touch. So here the tips are touching, here it's tip and tail, here it's tail and tail. So we want to find the angle between tail and tail. And so what I'm going to do is I know this is the opposite side, right? And this is the adjacent side. So I've got O and I've got A, opposite and adjacent. So if you remember your trig functions, SOHCAHTOA is tan of the angle is O over A, right? So that's the third part of SOHCAHTOA. And I can actually put numbers in here for O and A. So let's do that. So let me just erase the whole thing. So this is going to be tan of the angle is equal to 9.3 divided by 8.3. So let's find out what this number comes out to be. 9.3 divided by 8.3 comes out to 1.12. So then this is 1.12. And to get the angle, what I need to do on my calculator is called the inverse tangent. Okay, so you're on your calculator going to hit the second button and then hit tangent, and it will solve for this angle, because really this is your unknown. This is the x right in your equation. This is what you don't know. So do tan inverse of 1.12. So you're going to hit second and then hit tan and then 1.12, and that will give you the angle. And when you do that, it should give you an angle. And make sure, by the way, remember in physics, we will be in degrees, not radians. So if you don't get this, it's probably because you're in radians. So go to mode and switch it to degrees, and you get an angle of 48.3. And this vector, right, it's heading east, so this is east, and it's north of east by 48.3 degrees. So this is north. So here, let's see if we can get rid of. Can't get rid of it. So this is north of east. Okay. So this is your final answer here, and hopefully that made sense and helps you get these problems today as we're going to practice in class.